Welcome to the session on Matlab program to solve the equivalent resistance of series and parallel combinations. In this session, we shall have a recap of series and parallel connections. We should also have a recap of expression for the equivalent resistance. Then we'll see Matlab script for the series equivalent resistance using function, Matlab script for the parallel equivalent resistance using function. Then we should also see Matlab script for the equivalent resistance without using the function. Then in the end, we shall go through few multiple choice questions. You are seeing the series and parallel type of connections of resistors on the screen. As you all know, in case of series type of connection, the resistors are connected in the form of a chain so as to carry the same current through them. In case of parallel type of connection, the resistors are connected in such a way that the main current divides itself and flows through them. Now let's recall the expression for the equivalent resistance for both series type of connection and also for parallel type of connection. The first expression, what you are saying, is for the series type of connection. This is very simple expression. Here you are only going to add the values of resistors to get the value for total resistance of the circuit. Second expression, what you are saying is for the parallel type of connection. Here we will be considering the reciprocals to get the expression for 1 over R equivalent. Now we shall solve a simple problem. Equivalent resistance of a parallel circuit having two resistors of 12 ohms each is given by. So you have four choices. It is 8, 24, 6 and 0.167 ohms. So which is the right one? In case of parallel circuit having two resistors of same value, the equivalent resistance will be half of the given resistor value. So it's going to be 12 divided by 2, that is 6 ohms. So your answer should be C. We should see the next question now. The expression for the equivalent resistance of a parallel circuit consisting of three resistors R1, R2 and R3 can be written as. So here again you have four choices. So which is the right one? See, in the first expression, the right hand side expression, that is 1 over R1 plus 1 over R2 plus 1 over R3. See, this has to be equal to 1 over R equivalent. No, it should not be equal to R equivalent. So you cannot choose this. You cannot choose this as the answer. Then coming to B, see, this expression is for a series circuit, not for a parallel circuit. So you cannot go for B. Then coming to this D, see, this simplified expression will be equal to 1 over R equivalent, not R equivalent. So you cannot choose the answer as D. So the correct answer is C. R equivalent should be equal to the expression what they have. I mean the right hand side expression is right. It is correct for R equivalent. So your answer should be C. Now we should see one more question on equivalent resistance. The total resistance of the circuit will be. So here we are having three resistors connected in parallel form. So for this, you need to use this third expression. Okay, you can just substitute the values for R1, R2, R3 to get the result. So here you have four choices. The first one is 60 ohms, second one 5.45 ohms, third one 0.183 ohms, last one is none of the above. The right answer will be 5.45 ohms. This you are going to get it after the substitution. Now we shall see the Matlab script for series equivalent resistance. So the function program should always start with a keyword function. Then here I have used a variable REQ. I have just given the name as REQ. So in this variable, I'm going to store the value of equivalent resistance. Then after that, so UQUI underscore SR, what I have used is the name of the function. R is having the resistor values. In the next line, I have used the length function to know the number of resistors connected in a series circuit. So if there are two resistors, then N will be assigned a value of 2. If there are 3 resistors in a series circuit, then N will have the value of 3. Now we shall see the next statement in our function program. That is REQ is equal to sum of R. So here sum function is used to add the all the resistor values. So it gives the result as its result is going to be equivalent resistance of the series circuit, and that is assigned to a variable REQ. So REQ will have the result now, and that's what is going to be returned to the called program. Function should always end with an end statement. So I'm having an end here. Let's see the main program for series equivalent resistance now. So here I've used the CLC command to clear the command window. Then I'm giving the resistor values as 10 and 10 in the next statement. So A is having the resistor values. So here I've considered only 2 resistances. In the next statement, I'm just calling the function by its name. Now, what happens when we call the function? It is going to execute the function. Then function is going to return the result to this main program. Since we have given the resistor values as 10 and 10, the equivalent resistance is going to be equal to 20. So the 20 will be it's going to return 20 to this main program, and that is going to be assigned to a variable RT. So RT will have the value of 20. So the result is going to be RT is equal to 20. Now I shall show the execution of the program using Scilab, which is very much similar to Matlab. So here I need 2 files, one for the function program and other one for the main program. So I'm just clicking on new file here. Now I can see the editor to enter my program. I should enter the function program now. And since function program has to start with a keyword function, I shall enter the keyword function now. Function. Then the variable name, REQ. Then the function name. Just giving the name as EQUI underscore. Then the R, which is going to have the values of resistances. Then if you want, you can go for length function. Then the calculation part. So here it's going to calculate sum of all the resistance values. In the end, I can have the end statement. So now before running this function program, I need to save it. So here I need to give the same name what I've given for the function. So she'll give it as EQUI underscore sum. So after saving, I need to run this program. So I shall run it now. Now I shall go for one more file to enter my main program. So here I shall enter the main program now. So I shall start with CLC command to clear the command window. Then the inputs, just giving the resistance values as 10 and 10. Then I'll call the function. I need to save this file. So I'm giving a name for this file as series EQ underscore clear. Should save it now. Now I'm going to run the program. It is displaying the result as 20. ಹಾಗೆ ನಾವು ವರ್ಕ್ ಸ್ಪೇಸ್ ಬ್ರೌಸರ್ ನ ಗಮನಿಸಬಹುದು. ಏನಲ್ಲಿ 10 ಅಂತ ಸ್ಟೋರ್ ಆಗಿದೆ ರೆಸಿಸ್ಟರ್ ವ್ಯಾಲ್ಯೂಸ್. ಹಾಗೆ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ RT 20 ಅಂತ ತೋರಿಸ್ತಾ ಇದೆ. Now we shall see a question on function. How do you create a function file in Matlab? So here you are having 4 choices. The first one is begin M file with function definition. Second one is there is no such thing called function file. Third one is an M file is only a function file. Third one is none of the above. So which is the right answer? The first one, that is A, is the right answer because you need to begin M file with function definition. Now we shall see the Matlab script for parallel equivalent resistance. So here again I have used the keyword function, then variable REQ to store the value of equivalent resistance. Then I have given the function name as EQUI underscore PR. Here again R is going to have the values of resistors. In the next statement, I've used length function to see the number of resistors connected in parallel circuit. So n is going to be equal to 2 if there are 2 resistors. N will be 3 if there are 3 resistors. If there are 2 resistors in a circuit, then we need to use the expression REQ is equal to product of R divided by sum of R for calculating equivalent resistance. If there are 3 resistors, then we need to go for the other expression. So if n is equal to 2, REQ will be equal to product of R divided by sum of R. Product of R is nothing but R1 into R2. Sum of R is nothing but R1 plus R2. So by using this formula, we can get the value for equivalent resistance. Then when there are 3 resistors in a circuit, we need to use the next expression what is entered in the program. So using this expression, we can get the value for equivalent resistance. we need to see end statement for the if and also for the function. Now we shall see the main program for parallel equivalent resistance. So here again I have used CLC command to clear the command window. Then have entered the resistance values as 10, 10 and 10. So that means there are 3 resistors in a circuit. Then in the next statement, I'm calling the function by its name. So now ಈಗ ಫಂಕ್ಷನ್ ಕಾಲ್ ಮಾಡಿದಾಗ ನಾವೇನು ಫಂಕ್ಷನ್ ಪ್ರೋಗ್ರಾಮ್ ಎಂಟರ್ ಮಾಡಿದೀವೋ ಅದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುತ್ತೆ. ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗುವಾಗ 3 ರೆಸಿಸ್ಟರ್ಸ್ ಇರೋದಕ್ಕೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ 3 ರೆಸಿಸ್ಟರ್ಸ್ ಏನಿದೆ ಅಲ್ವಾ ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅದು ಯೂಸ್ ಮಾಡ್ಕೊಳುತ್ತೆ. ಅಂಡ್ ಫೈನಲ್ ರಿಸಲ್ಟ್ ಏನಿದೆ ಅದು ಮೇನ್ ಪ್ರೋಗ್ರಾಮ್ಗೆ ರಿಟರ್ನ್ ಆಗುತ್ತೆ. ನಾವೀಗ ಪ್ರೋಗ್ರಾಮ್ನ ಹೇಗೆ ಎಂಟರ್ ಮಾಡಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡೋದು ಅಂತ ನೋಡೋಣ. ಸೊ ನಾನು ಅದನ್ನ Scilab ಅಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದ್ದೇನೆ. ಸೊ ನೀವು ಸೇಮ್ ಸ್ಟೆಪ್ಸ್ ಫಾಲೋ ಮಾಡಬೇಕಾಗುತ್ತೆ Matlab ಅಲ್ಲಿ. ಅದರಲ್ಲೂ ಕೂಡ 2 ಫೈಲ್ ಯೂಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ, ಎಂ ಫೈಲು, ಫಂಕ್ಷನ್ ಫೈಲು. ಸೊ ಈಗ ನಾನು ನ್ಯೂ ಫೈಲ್ ಅಂತ ಕ್ಲಿಕ್ ಮಾಡ್ತೇನೆ. So now in the editor I can enter the program now. So the function program has to start with the keyword function. So I'm going to enter function and then the variable name, then the function name. In the next line, I'm going to use the length function. Okay. Next line, we'll have the if statement. So if n is equal to 2, then I need to enter the expression for equivalent resistance. So R equivalent will be equal to product of R divided by sum of R. Then I need to have else if n is equal to 3, and R equivalent will be equal to, I shall enter the expression now for 3 resistors. So now I shall use the end statement for else if, then end for the if, then for the function. Now I'm going to save the program. So I shall give the name as EQUI underscore PR dot save. Now I shall run this program. Now I'm going to enter the main program in a new file. I shall start the main program with the CLC command. Then I'm going to give the resistance values. Then I shall call the function. I'm going to save this file by giving a name. So now I'll run the program. It is displaying the result as RT is equal to 3.33. So that's how we enter and execute the program. Now we shall see a question on Matlab code. So given the Matlab code, A is equal to 382, P is equal to length of A, the result would be. So you are having 4 choices. So which is the correct answer? So ಇಲ್ಲಿ length of A, length function ಏನಪ್ಪ ನೋಡುತ್ತೆ ಅಂದ್ರೆ ಇದು A ಏನಿದೆ ಅಲ್ವಾ ಅದರ ಸೈಜ್ ನೋಡುತ್ತೆ. ಸೊ ಇದು 1/3 ಸಿಂಗಲ್ ರೋ, ಇಲ್ಲಿ 3 ಕಾಲಮ್ಸ್. ಸೊ ಅದರಲ್ಲಿ 1, ಸೊ 1/3 ಅಲ್ಲಿ 3 ಗ್ರೇಟರ್ ನಂಬರ್. ಸೊ 3 ಅನ್ನೋದನ್ನ ಅದು ಕನ್ಸಿಡರ್ ಮಾಡುತ್ತೆ. ಸೊ P will have a value 3. So you need to go for the third answer, that is P is equal to 3. So now we shall see a Matlab script without the function code. So here in the first line, I've used a printf statement to display the text what I have entered within the brackets. So a printf is going to display this text on the screen. So we are going to ask for the resistor values. Then in the second statement, I've used input function to display the text what is there within the brackets and also to accept the input from the keyboard. So this second statement is going to display the text as enter the value of resistance R1 in ohms, and it is going to wait for the input from the keyboard. And the value entered through keyboard is going to be stored in a variable R1. Then for R2 and R3 resistor values, I am using the same procedure. Same commands are used for getting the values for R2 and R3. Then after that, I have written a statement RSQ is equal to R1 plus R2 plus R3. So this is for the series type of connection. So for series type of connection, the equivalent resistance will be sum of all the resistor values. So this is going to RSQ is going to give the equivalent resistance value. Then in the next statement, I'm going to calculate 1 over R1 plus 1 over R2 plus 1 over R3. But this is not the actual value of the equivalent resistance when resistors are connected in parallel form. I need to calculate the reciprocal of this RP. So RPQ is equal to 1 over RP. So the final value for equivalent resistance is going to be stored in a variable RPQ. Then using a printf statement, I'm going to display the result. Now we shall see one more multiple choice question on Matlab code. So here the expression, so there's a expression in the second line. So what they are asking is whether it displays the text in prompt with what is there within brackets, whether it is going to display the text, or whether it is going to wait for the user to input a value and press the return key, or displays the error message for an invalid expression, or whether it is going to return an empty matrix if user presses the return key without entering anything. So which of the statements given above are correct? See here, the input function is going to perform all the function what has been listed out here. So the right answer is E, all of the above, because it is going to display the text what is entered within the brackets, and it will wait for the user to enter the value using the keyboard. It is going to display error message if there is an invalid expression, and it will return an empty matrix if user presses the return key without entering anything. So the right answer is E. If the result of our summation is infinity, what will Matlab show? So again, you are having 4 choices. So which is the right one? So here C is the correct answer. So it is going to show it as INF. Now we shall see the next question. Variables need to have same name while being passed from the primary function to the sub function. So they're asking whether it is true or false. So here it is false. They need not have same name while being passed from the primary function to the sub function. So right answer is B. We'll see one more question on Matlab code. What is the output of the following code? So if x is equal to 20, var is equal to 10, end. So here a single equal sign is used, which is used as assignment operator. So if we use this single equal sign, then x will be assigned a value of 20, which is wrong over here for if statement. So this code is going to give an error. So right choice would be A. So in this session, we have seen the Matlab scripts for the equivalent resistance of series circuit, and also Matlab script for equivalent resistance of parallel circuit, and also few multiple choice questions. So that's all for this session now. Thank you.